Welcome to Lab 9. This is our Snell's Law lab. And before we get going with all the equipment and the measurements, I'd like to talk briefly about the theory. So this is our Snell's Law lab. Snell's Law is generally describing light or a wave in general traveling from one medium to another medium, or one material to another material. And as it travels from one material to another material, the angle at which it's coming in changes based on the information about that material. So it's often written like this: N1 sine of theta 1 is equal to N2 sine of theta 2. And let's unpack that a little bit. Let's create a boundary, and above this boundary we're going to put air. We'll say this is the N of air. By the way, what we mean by N is the index of refraction. It's just a number that describes that material. In this case, the N of air is equal to 1. No, actually, that's true of all the cases. And let's say that we've got our light traveling from the air surface into this water surface. We're going to put the N of water down here. So we've got air and water. And so let's say the light's coming at an angle that looks something like this. And as it transitions from the air to the water, it's going to come out of that surface at a different angle. And the way that we will measure these angles is from the perpendicular to that surface, something like that. So here's theta 1, which I guess let's just call theta air. And here's theta 2, which I'll call theta water. And if you plug the numbers into our Snell's law equation reasonably, then you could figure out what angle each of these are, or maybe even the index of refraction of water. It's actually a good way to understand what kind of surface you're looking at a lot of times. There's one other small thing that I want to describe, which is if you had light coming in perpendicular, I'll bring it over here, let's say. If your light is coming in perpendicular to the surface, well, your theta is 0 in this case, which sine of 0 is 0. So that, therefore, the theta 2 also has to be 0. So if the light is coming in perpendicular, it's leaving perpendicular. It's only when the light is coming in at an angle does it bend and change from one surface to another. All right, we're going to be using this equation and these ideas through the rest of the lab. So take some notes, and I'll see you in the next video.